The infamous shadow problem. This came up on the AP a few years back, so we gotta know how to do this one. It's a great question, especially around Halloween time. You can find how long your shadow grows. I think it's pretty easy. It's just similar triangles. Gandalf stands 6 feet tall, and he can walk at a rate of 5 feet per second towards the light. Now we're walking towards the light, so what's happening to that distance? Remember, the distance is decreasing. So therefore, my rate here will be less than 0. It's going to be negative. So what do? I always start off with a picture. So I'm going to draw my picture. Okay, we have a light post 16 feet tall. A certain distance away, we have a very skinny Gandalf, right? We have a very skinny Gandalf. And light comes out, hits him on the head, and goes to the ground. And then we have this distance right over here. So Gandalf's height is 6 feet. The question says, at what rate is the tip of a shadow when he is 10 feet from the base of the light? So we have a bunch of distances right here. So let's start thinking. Anything that changes gets a variable. Notice the height of the lamp doesn't change. So I just keep that at 16. Neither does Gandalf's height. It never changes. But what does change is the distance Gandalf is from the light. So I'll call that A. But also, this distance is going to change. B. Now, B is kind of an interesting part. B is the shadow itself. But I have another length, and that is this distance right here. Anytime we measure the tip of a shadow, we always measure to the light post. So this is the tip of the shadow. And we'll call this whole length C right there. Just to have everything. Give everything a variable that changes, right? Anything that changes is a variable. So I'm going to go ahead and list out my givens now. My first given, they tell me how fast Gandalf is walking. Well, if Gandalf is walking towards the light, that's changing B. So that is dA dt. Remember, it's going to be negative because that distance is decreasing, so we have a negative rate. Next thing we have, at what rate is this tip of a shadow moving when he's 10 feet? So they're telling me A is 10 feet when he's from the base of the light. And then they ask me to find the tip of a shadow. How fast the tip of a shadow is moving. So we're asked to find dC dt. Alright, so I need to set this up, of course. And so there's everything. So I need an equation. Now, a lot of times people think, oh, Pythagorean. Pythagorean is not a really good place here because we don't know the hypotenuse. But we can find it. Yes, you can, but it's just more work for us. I'm going to use similar triangles instead. Okay? In similar triangles, I can look at the big triangle, the 16 to C. 16 matches up with that C right there. And that's going to equal my little triangle. The height of Gandalf, which is 6, to the length of his shadow, which is B. So now I remember, okay, I am looking for C. So I need to replace B. I'm going to replace this, okay? How to replace B? Well, is there anything here that I can use to replace B? See, I know A, and I'm looking for C. I don't need B. I don't need this length right here. I don't need the length of a shadow. I am given A, and I'm looking for C. So is there any way I can write B in terms of A and C? And of course, I know that C is A plus B. Therefore, B is C minus A. And that's what I'm going to write here instead. So I'm going to go 16 over C equals 6 over C minus A. Solve. I get 16C minus 16A equals 6C. Now at this point we can take the derivative, but we're not because it's nasty. But I'm going to solve instead. I get 10C equals 16A. And if I divide, I'm looking for C, so I'll solve for C here. C is 8 over 5A. And there's my equation I'm going to use. This derivative is much easier to take. I could have taken the derivative here. Quotient rule, not going to happen. So I solved it. So I get dc dt equals 8 over 5 dA dt. And I know what dA dt is. It's negative 5. Notice, do we really have to plug in A? No. So what that tells me is that the distance Gandalf is from the light post doesn't determine how fast the tip of his shadow is moving. It's always moving at a constant rate. So I can just plug in dc dt equals 8 over 5 times negative 5, and we get negative 8. And it should be negative because he's heading towards the light post. So, I ran out of room here. Units, so this becomes negative 8, c is feet, t is seconds. So his shadow is actually moving faster than him, and that should make sense because once you're over the light post, you and your shadow should be directly at each other. If your shadow's tip moves at the same speed, that means when you reach the light post, your shadow's not quite there yet. And you would write this as a sentence. I ran out of room. I'm kind of a hypocrite. Write that as a sentence. The tip of the shadow is decreasing at a rate of, or heading towards the lamppost at a rate of 8 feet per second. Now the next part, pretty easy to do. At what rate is the length of his shadow growing when he is 10 feet from the base of the light? Now we want to find out how fast the shadow is growing. That's B. So here we want to find dB dt. And this is so easy because we actually already have it. Remember, we already know that B is C minus A. So I know dB dt is dC dt minus dA dt. And dC dt we just found was negative 8 minus dA dt. Where was that again? Oh, there it is, negative 5. And we should get negative 3 feet per second. I'll write this one as a sentence, okay? So what is this saying? The shadow's length, instead of increase, is decreasing at a rate of 3 feet per second. And it should be decreasing because, again, he's moving towards the light. The shadow should be getting smaller. Next time you guys walk towards the light, watch your shadows. Is it growing or is it shrinking? Just make sure you count the shadows. All right, you guys have a wonderful time. Hope you guys enjoyed all these videos. We'll see you next time. Oh, here's a fun one for you. Just pause right there, take a look at that. Kind of a fun one for you to answer if you feel like it. Bye.